Okay, so sketch this function indicating the important features, including all of this stuff. So we're going to go straight to drawing. I've input my function. That's what it looks like. Now we're going to have to solve for a couple of pieces of information just to double check that they are what they look like. So first thing, the domain. So the domain is all of your possible x values. You can see that your function doesn't exist over here in this quadrant, and that's because your asymptote is equal to 0. Now, how do we prove that it's equal to 0? See this little thing in here? Boom, there he is. So your log functions have asymptotes that run down this way with the g. There's a log in g, there's a y. See how they've both got this little tail? That means the asymptote runs down, parallel with that axis. So I let whatever's in that bracket equal 0, and then that is the vertical asymptote. Now, looking at this graph, so I can see that if that's the asymptote running along there, this value is going to get close to but never touch it. So then I can start talking about the domain as 0 up to x, all the way up to infinity, not touching it though. So that's the domain. Okay, now we're going to look for the intercept. So that's A, B intercepts. So G-solve, get a root when x equals 1, y equals 0. G-solve, y-intercept. You don't get one because it's asymptotal at that axis. So there's my intercepts. We've done that, we've done that. Intervals on which the function is increasing and decreasing. So to find that, we need to calculate the derivative of it. So f, or dy over dx equals d over dx bracket ln x over x. So we're going to calculate the derivative of this function here. And because we've got an x on the top and x on the bottom, both got a term of x, so it's quotient rule. So u equals ln x, u dash equals 1 over x, v equals x, v dash equals 1. When I substitute this into my function, so f x, the derivative of it is equal to, it's always v first, so x times 1 over x, subtract ln x, that times that is just that, okay, 1 times anything doesn't change it, and that's all over x squared. Now the next thing is this will cancel that, so on the numerator I'm just left with 1 minus ln x over x squared. So to calculate the stationary point, that's when I'm going to let fx equals 0. The derivative equals 0, and that finds me my stationary point. Okay, so 0 is equal to 1 minus ln x over x squared. Take this to the other side. 0 times anything just gets rid of it. So I've still got 0 is equal to 1 ln x. Now I'm going to move this to the other side. ln x is equal to 1. That means I take ln across, and it will become base e to the power of 1. So x is equal to e. So there is a stationary point at e. Now, if I want to find the intervals on which the function is increasing and decreasing, all I have to do is look at the sketch of it. Shift. We want to input x, so we're going to calculate y. Shift e to the power of 1. Execute, there it is. So you can see here on this side it's decreasing and over here it's increasing. So for C, the values where it's increasing are going to be from 0 all the way up to x, all the way up to e. Now for the values where it's decreasing, increase. Now, if it asked me to prove it, I'd just pick a value in between these two, throw it in, and it should give me a positive value in the second derivative. Okay, next thing, e all the way up to x, all the way up to infinity is decreasing. Done. Local max, well, I've got it up already. If that is the stationary point, and we can see that it's increasing here, decreasing there, then that means it's the maximum. So D, max, equals when X is E, Y is 0.3679 to 4 decimal places. It didn't ask me what decimal place to go to. So either I can roll with that or I can round it to 2 decimal places like we normally do. Okay, that's you done. Horizontal and vertical asymptotes. So we've already determined the vertical asymptote is when X equals 0. The horizontal asymptote is when, what is Y equal to? Or when, yeah. Okay, so we're looking at solving the denominator here. We want that, the values of that to equal 0. So in this case, X equals 0 as well. Now at the start of the video, I said there was something that I wasn't 100% sure on. I'm not 100% sure how our horizontal asymptote is when Y equals 0. Because if that's true, then it shouldn't be touching here. But I checked the answers and they said that's right as well.